Okay, good morning, all of you. Today we'll see the third unit. We can proceed the third unit, evaluationary algorithm applications power engineering. In that, the third unit is modified particle spam optimization. In this, before going to in detail of what are the modifications in basic PSO and all, we'll see first review of this particle spam optimization. Maybe if anybody want to do research or already maybe used this algorithm in your past research and all, know this. But otherwise, that is the reason I will start with basic PSO initially, or you can say review of the PSO. PSO means particle uh, spam optimization. So in that, after invention, what are the modifications happened that we can see it in this class. Now, the syllabus in this, we have introduction. Yeah, it's not GA, PSO. Introduction to PSO, and then just a minute. This is PSO and the review of basic spam optimization. That is the basic things we'll review. And then what is the background of PSO and variations of PSO, discrete PSO and all. We'll see some of the parameters, how it is going to be vary that we can consider. These are the modifications. We can see that construction factor approach, CFA, and then hybrid PSO, and then adaptive PSO, and next one is the evolutionary PSO. So these are the modifications. Earlier, basic PSO are there. After that, the research are doing very well because this PSO algorithm is a origin for all the natural inspired type of algorithms. In that is the reason many researchers are used this and they developed many things. In that case, the factors earlier, in the basic case, it is all fixed, some of the constants and all. Now, what we can do is we'll see one by one what is the construction factor approach and hybrid PSO and adaptive PSO and evolutionary PSO. All these things we'll discuss. And what are the research areas and applications? This is a brief about in what type of applications they have used this PSO algorithm. And that is more or less literature. You can identify huge applications in the real world problems. They have used this PSO. And then we'll see like what we did in the last unit, GA. In that case, we have taken the problem and we solved the different types of there in the case of real coded genetic algorithm, binary coded, and in turn crossover types they used and mutation because they have different types of mutations as well. Like that, they use it now with example. Now also, what we'll do is we'll take it as a sphere function. How we are going to solve using PSO algorithm, we are going to implement in this. Once if you are aware the basic things, the rest of these parameters, whatever we have mentioned as a consecutive factor and hybrid and adaptive and then evolutionary, all these things, small changes with respect to basic problem. Whatever we solved sphere function, we're going to solve sphere function using PSO. That thing we can able to solve here with the constructive factor approach PSO, that is CPSO, and then HPSO, APSO, EPSO. What are the modifications we required that we can do it in this mechanism? Now, introduction. Particle spam optimization in the short form. Now, I will always use this word as a PSO. Was developed by Kennedy and this guy in 1995. The first they proposed in 1995 has become one of the most widely used spam techniques. Group of animal, group of insects like that. Swarm means group of things. Algorithm due to its simplicity ability. And this algorithm is having as a very good simplicity flexibility. Many new algorithms that are based on spam intelligence may have drawn inspiration from different sources. So that's what I mentioned. No, because of this simplicity and flexibility in PSO, many algorithms later is developed. As I said, no, cuckoo search algorithms, cat algorithm, like that. Many kind of algorithms they have used this is a basic intelligence, the inspiration from the different sources. In this sense, PSO pioneered the basic ideas of spam intelligence based computation. The PSO algorithm searches the space an objective function. Like, something you want to search as objective function, let it be as objective function is nothing but our goal. We need to identify the minimization or maximization, whatever that we need to identify using the SWAM intelligence technique by adjusting the trajectories of individuals agents called particles. So here agents or particles are both the same. Group of people or group of agents is going to search and then it identifies the best solution. That's what we can see. And PSO is a uh, stochastic optimization techniques based on the movement and intelligence of spams. And concept of social interaction is used for solving the problem. It uses a number of particles, that means agents, that constitute a swarm moving around the search space. So let it be, these are all lot of agents and these agents is moving around the search space to select as a best solution. Looking for the best solution. What agents will do, again, this concept is common for all type of algorithms. What we can do is the agent or group of people is all working parallelly and exchanging their information. Based on their information, they can able to do their job, and finally they have to find the best solution. Each particle in the swarm looks for its positional coordinates in the solution space, which are associated with the best solution that have been achieved so far by that particle. It is also known as the p-best. Here, two things you have to remember. There is a p-best and g-best. P-best is also called as a personal best. G-best also called as a global best. What we can do is, while you are writing the exam, whatever marks you scored, that is your personal best. Individual, every student have their own marks. That is what the best are also called as a personal best. But once you want to identify who is the topper, then who is having the highest percentage, there will be treated as a global best. But for him, that is also called as a personal best also for the topper case. The rest of the persons, whatever their individuals, that is a personal best. And among the class, or among the group of people who is having the highest percentage will consider as a global best, like that. That is only small thing we need to remember what is the difference between personal best as well as the global best. That's what I mentioned. Other best value known as the G best are also called as a global best is tracked by the PSO. This is the best possible value of for by a particle in the neighborhood of the particles. So group of people they are searching in that you can see suppose 10 people are involved in the searching process. Whatever this fitnesses that will be as a personal. Among all who is having as a best fitness that value is a G best. Individual best we call it as a P best. That is a personal best. That's what we are going to do. Now you can see this image will how it is going to be search a food. Searching food is identifying the food itself as our goal. Let us assume that. Now what these things will do, they are moving around the space and they're exchanging their information and they're going in the right direction. And once if it reaches the, or you can say it is identify the food source, that is only their goal. That's what we can see. Now, whatever I mentioned, G best and P best, we can see here in each iteration or something. Who is the having highest magnitude in the maximization problem? And this is a global maximum. That's what we'll get it as a global maximum. Is a minimum point we can see as a global minimum. Highest value will treat it as a global maxima. Lowest value we can say as a global minimum. If you want to see individual case, the what is the G best here? This highest maximum is a G best, highest minimum is also as a G best in the case of minimization problem. In the case of maximization problem, highest value will treat it as a globe. But what is the P best? All individual, suppose in the case of minimization problem, this value, all these things we consider as a P best of particular agent in that position. Once if you know mm, the P best and then G best, we can observe that what will happen in the case, based on this information, we are going to exchange this information to other agents. Then they will change their directions and positions to reach their P best to be as a G best, like that. Once if he is a topper or his fitness is more, then become as a G best. So all others will follow the direction of G best side so that he also will reach in the best solution like that. And now you can observe here some more information. PSO is based on the social behavior of the animal groups. How the animals is going to behave, based on that it is developed. Sharing the information among the group increases the survival advantages. But if all four peoples are searching one particular object, if they in the different directions and they exchange their information, I mean so and so that my position is maybe nearest to that object, or some other guy is maybe going to wrong direction and his path may be uh, far away from the object like that. If we identified in that manner, we can easily catch him or once the information is passed and then The other guy who is going in the wrong direction, he may turn back or he will move in the right direction. That's what here you can see that social behavior of animal group, and then they are exchanging the information. Or not only animals, this bird searching for food randomly can optimize here, searching if she works with the group. It is easy once they are the group. That is what we can do is the searching process with exchanging the information is the best way. The advantage of working in the mutual sharing of the best information, which can help to group to discover the best place to hunt or to identify the food source. Each particle represents a candidate solution, or also called as a P-best. That's what we can see. And in PSO system, particles change their position by flying around, because it is a birds or animals. What it will do is it is always is hunting for food, and change their position by flying around a multi-dimensional such space. That means it's randomly will fly. Once if it randomly fly all the agents, and then they exchange their information, based on that another move will takes place. That is the way we can see how the searching process will be takes place. And then maximum computational limitations are exceeded, then the problem we can stop. That means stopping criteria and all. Now in this movement towards the promising area to get the global optima. That means global optima is the final solution. That's only the each particle adjusts its traveling velocity dynamically. It is not fixed. Whatever velocity that is going to move, in that case, that is the one point. We can observe that it will be as a velocities dynamically according to the group experience, and it as a, and colleagues in the group. Each particle tries to keep track of the best results for his or her known as possible P best, and best value of the particle is a global best. This we call it as a global best. Each particle modifies its position according to its current position. Where you are, suppose you are here, based on the current position with some velocity, it will move. Then the new position is going to arrive, and its current velocity, the distance between its current position and P best, the distance between its current position and G best. This we are going to see the current position, current velocity. Based on that, we can find the new position and new velocity. And we'll see what are the steps involved in the PSO algorithm. Because to solve the problem, we have as a step-by-step procedure how the solution will arrive using the PSO. Like that in the what you call it a genetic algorithm also, what we did is there initialization, then selection, then random generation, that is initial population. We are finding the fitness and all. Then we'll go for as a crossover operation, mutation operation until the stopping criteria is reached. Then we are going to stop that process. That is what we can use as a problem. Now we can see PSO algorithm. First one is a initialization. For all the algorithms, we will get initialization first. Now the define the population size means there also we did in genetic algorithm also what is the population size that we can fix it. There also, as I said, now NP number of population. You can take for a project while you are doing the programming part, you can take 50 populations or 100 populations like that. But whenever you want to do manually, we can take it as a 4 or 5 or something for our better understanding for simple calculation purpose. That is one thing. Define the population size, then initialize the position and velocity of each particle randomly. So we have to start somewhere. So that is the initial position. Suppose I want to search from here to many people are there, wherever they stand, that is their own initial population and random velocity when you want to move. We can take for that we have to generate randomly that we call it as a position and then velocity. Randomly we have to choose within the search space. After that, define the fitness function. So how the fitness function will, once we know the variable, let it be, we observed in the case of GA, no, what you call it as real coded genetic and all. X1, X2 is suppose the random values 1, 2, 3, 4, then 1, 5, some random population, let it be population 1, population 2, 3, and so on. And your function is, let assume that square function x1 square plus x2 square, let assume. Then the first step is number of population. Let it be, this may be 3, let assume that. Then second step is initialize the position and velocity vector. Let it be, this may be position. And similarly, velocity vector also required. And you have to calculate the fitness function. And suppose if this is the case, 1 square plus 2 square, 5. And then fitness vector, you can create only one value like that. You can write for first value is 5, then second value 3 square plus 4 square, then third value 1 square plus 5 square. All these things you can write. That's what the third one. And define the fitness function that evaluate the quality of particle position. And next one is evaluation. The evaluate the fitness of each particle using the fitness function. Evaluate the fitness of each particle using fitness function. Suppose whatever I used the previously, that I call it as a function value. Some problems function value and fitness value they consider same. But here, suppose once if you know function value, then we can easily find the fitness value 1 by 1 plus function value if it is a positive. Or a negative means 1 plus fitness function value modulus. This will be as a fitness value. Using this formula, we can easily calculate. That's what second step. Evaluate the fitness of each particle using the fitness function. And third one, update the particles the best known position, that is the P best, and the corresponding fitness value also you are going to update. And then initialize the global best. What is the global best? In a population based on the fitness, who is having the best fitness, corresponding population vector in that row, we treat it as a best solution. So now identify the particles with the best fitness value among all particles. Set the global best means whatever we identify the best solution, that we call it as a global best to the position and fitness value of this particle. Now, next step we can see update the position and velocity. Now you are here and some other guy is here, some may be here. With some velocity, we are moving. Update the velocity of each particle. Now this is the position. Now we'll move with some velocity. This is the position, starting position. After that, with some velocity, we are moving. So once if we are moving to there, that we call it as a velocity update. So update the velocity using this function. Initial and position. From there, we are moving with some velocity. After that, we can easily update the new position also. In this case, update the velocity of each particle using the following formula. We can observe new velocity is equal to W into old velocity, C1 constant, R1 random value, P best in that particular row or particular what you call it as population minus current position, then plus C2 into R2 into G best minus. So what is the formula? You can easily remember. P best minus Xi, that is one factor multiplied with some constant. Constant is C1 into R1 plus C2 into R2 into, instead of P best, you can take it as a G best minus Xi. So like that, we can easily identify or update the velocity. These parameters you can see here. Vi is the velocity of a particle at particle I at that particular time, because I is 1, 2, 3, and so on based on the number of populations you have taken. That means each person or each individual will keep on doing that. So that is the VIT plus 1 that will give us a velocity updation. And W is the inertia weight. And C1, C2 are acceleration constant, cognitive and social components respectively. So now this is the methods I am going to use in the later point of time. C1, C2 are the fixed constant as per the basic PSO algorithm. Later point of time, we are able to constructive factor approach. So in constructive factor approach method, we are changing the C1, C2 values. That's what I can see. C1 and C2 are acceleration constants. That is a constructive factor approach. Now, R1, R2 are the random values between 0 to 1, because here C1, C2, initially will fix it C1 value and C2 value may be 2 something. Then R1 will be random value and P best is known, and current velocity, the X position, the solutions for the random population will take it as Xi, means I is 1, 2, 3, and so on. And among the random, based on that fitness, we can use as a best fitness value, that is a global best minus the corresponding position. That means what we are doing is with respect to individual best and with respect to global best, we are going to modify, because as per the instruction or as per the information received from the other agents, we are going to modify. We have to find the distance where I am, what they are, uh, who is the global best. Global best is the best direction in that case. So we are in maybe in the different direction. So we have to move that in towards the right direction. That's what here we can see C1, C2 and R1, R2. And as I said, P best is a best known position of the particular particle, and Xi is the current position of that, and then G best is the global best position among the agents. Who is the best? That will be as a G best. So now update the position of each particle using the formula. Now the position, new position, we can get it easily. Reason is once if we know current position and with velocity, if we add these two things, we'll get the new position. It is straightforward. Now I'm here. In this, what I will do is I'm moving with some velocity. Then I want to know what is this position. How can I get this position? This will be this current position plus with velocity. Then that will give as a new position. That is what the difference. We are adding current position or simple logic. You are in CB80, you are moving 20 kilometers. What is the new position? This origin point plus 20 kilometers will give the new position. Same thing. Like that, we are going to obtain the updated position in a particle. This formula, the new position is equal to current position plus new velocity. New velocity will come here. And then current position, initially randomly we are generating. Based on that, we'll get it as a current. Now, after that, we need to update the particle uh, best known position, the P best. So what is that means is whatever random values already known to you that is individual. Suppose this is a analogy like this. You have the results, maybe first semester results. Suppose is there any chance of writing as a betterment? Let us assume that. Now you wrote the betterment also. That also you got the result. Now with you, we have two results. One is the initial attempt, then betterment results. Then what we have to do update the COE will cross check these marks. Suppose you got A grade in the general exam and B grade in the betterment exam. Then what is the consideration? In the previous exam you have A grade, but now you got a B grade. So therefore, second exam must discard. You have to keep first exam as such. Similar manner, we are doing initial positions. In their situation, that information is known to you. Then we are moving some step. New position will arise, new velocities, and we'll compare these two whether you want to consider the second solution or a first solution. That thing we can consider. In that, if the fitness value of the new position is better than the fitness value associated with the particle best known position, update the particles best known position. So if the fitness value of the new position is better, that's what I told. If the betterment marks are better, then you consider that, or if the previous solution is a better, then discard the betterment exam. Like that. That's what this sentence says. The particle's best known position, update the particle in the best position. So now what is, we have A grade initially for roll number 1, let us assume, and later you got the B grade. Now what is the updation? You need to make it only A. Or here maybe yes, let us do that. Now the updation must be yes. So this is what the best updation. Now a global best. Now everybody, some four members, three, four, they wrote the exam. Let it be A, B, C, D grades. And from here, global best is A because this is the highest. The corresponding person is roll number one. Then again, they moved or they wrote the betterment exam or maybe second sem exam like that. So three, four. Then they got like this, or maybe yes, and here maybe B. In that case, these individual bests are different. The first guy individual best earlier is A, now it is B. So individual best only A. And then this guy is B. The now second is C. So now individual best is B. And this is yes. Now individual best is yes. And this will be as a B. Individual best. This is the P best. Now I want to know G best. What is the G best earlier? It is A is a G best. Corresponding person is roll number one. Now what is the G best? Now the G best is because S grade is the highest. So more fitness. Let it be the G best is yes. Corresponding roll number person is a 3. Now we updated the G best. Earlier we updated the P best. We update the P best and later we can update the G best. This is the way we have to update the P best as well as the G best. Now, termination criteria, we can see that repeat this step 4 to 6 at a termination criteria is met. Now, this process every time, now we are finding the fitness value and you can check with the random fitness value and then you have to repeat again position modification and velocity update, position update, then P best, G best update. This we have to do continuously until criteria. What is the criteria? Uh, we can see that we call it as a termination criteria. What is the termination criteria? Number of iterations may be 100. You can keep that many times. That loop is going to be repeated. Finally, we can call it as a termination criteria. Once that is reached, that's what repeat this step 4 to 6 until termination criteria. Termination criteria is nothing but a maximum number of iterations, finding the satisfactory solution. Suppose if we fix the 100 is a maximum number of iteration, you can keep that is 100 and you can repeat that. And then results. Once the termination criteria is met, the PSO algorithm returns to the global best. Whatever solution we are getting in that global best is our final solution. Found which represents the solution to the optimization problem. So this is the PSO algorithm steps. So 8 steps are there. We can proceed with step by step process. We can recall it is very simple initialization. Whatever parameters are there, you can make it as a parameter. Then evaluation, then initialization of the G best, and then update the velocity and position. Once if we update the velocity and position, then we can easily update the G best and P best. So once G best and P best is uh, clear, then we can easily find this. So that's what the termination criteria is going to be reached. The results once the termination criteria is met, the PSO algorithm returns to the global best position. Find the represent the solution to the optimization problem. So this is the algorithm. Now the formula is mentioned now velocity updation. New velocity is equal to W into old velocity plus C1 into, and this is what we can randomly select U or R. Let it be, don't confuse, make it as a R. Then we can come to this point. There is a P best, and another one is a G best. So once if we get P best and G best updation, then we can easily go for the bank account. So now we have to repeat this process until the condition is met. What is the condition? We can get it as a maximum condition number of iterations. Now that's what now using this logic, and we have to apply our procedure to find glow solution. For that, social behavior of birds all we already explained. Mm, birds flocking and fish shocking, schooling, and each particular bird has a position and velocity associated with it. Particle change the position by adjusting their velocity. That is a seek food, avoid a predator. What they will do, particle change the position by adjusting their velocity. How the position, suppose if birds are there, if any hunter comes, then you have to escape from him. That's what we can say. One aspect, the bird has to seek the food is maybe object, then avoid predators. You have to escape from him and identify the optimized environment parameters. So that C1, C2, all these parameters we have to identify as a best solution and identify optimized environmental parameters. Each particle memorize the best location identified by it. Particles communicate the information regarding the best location explored by them. Velocity of the particles are modified by using flying experience of the particle, flying experience of the group. So now we can see the same formula what I shown you in the previously, velocity formula, and then position formula. So velocity updation and position updation. V1 is the velocity of the ith particle, and if you want, you can make use of t plus 1. This also xi t plus 1. That way also you can mention it. The or otherwise, this will be new velocity new is equal to w into velocity old. That formula, any notation you can follow. And velocity of the ith particle, inertia of the particles, C1, C2 acceleration coefficients, R1, R2 randomly it has to generate 0 to 1, any value it may be, and then P best and G best, personal best and global best. Then position of ith particle, then we can see evaluate the objective function Fi and update the position. Irrespective of the fitness, update the P best and G best. So here, when you are going to update, as I given as example in the previous, if you have as a good grade in the betterment, you will update the position or let it be in terms of velocity, or once if velocity is updated, then automatically position also going to update. In that case, first we can see the whether P best updation or a G best updation. When we move what you call it as a P best, whatever personal best is there, it is the P best. But once it goes to something group of people, then individually you have to check whether previous P best and now P best. If it is changed, then you make it as a uh, group G best because all fitnesses. Now that's what we can see P best and xi. So what we have to assign if function value is less than P best particular value have to go with this, or otherwise G best also is a global more fitness than that we can consider as a G best. Now the cases you can see some possible case to understand our function value is x1 square plus x2 square and so on. It may be any number up to x4 also can take it. And, function value is x1 square plus x2 because this is the function I have taken. X1 square plus x2 square plus x3 square plus x4 square. Each value x1, x2 and up to x4, the minimum value is 0, maximum value is 10. That's what the problem is given. Now we can see how the updation position cases are going to be modified. Case 1, x value 5 and 6. If I keep this or let it be as x1 square plus x2 square is our function. X1 square plus x2 square is our function. Now if x value is 5, 6, then put it there 5 square plus 6 square. Then our function value is 61. And P best on the earlier data, we can see the P best value previously. You may be in the previous iteration, x value is 4, y value is 5. Then P best function best is 41. And global value, because it is a minimization, x value is t and our x1 value is 2, x3, x2 value is 3. So 9 plus 4, 9 plus 4 is 13. So this is the global. Now we can see what we ought to do, whether it is going to update or not, that decided by the uh, function value. Now here function value is 61. So what will happen? 61 is greater than the P best. P best value is here is a 41. Here is a 61. So we don't want to update because this one is the best solution. The first attempt maybe you got for this maybe mm, A grade and this may be B grade. Now we don't want to update B grade. So what you have to keep it as A grade itself. And G best also, it is not become as a G best. This guy will not become as a G best because already G best value is 13. That is a minimum function value. But now we got 61, so it never become as a G best. So what we can do, we can discard this solution. We can carry forward P best and G best. That is the one case. And other case you can see case same x value some other value. You can see 4 and 3 maybe x1 and x2. If I put that x1 square plus x2 square, we got it as a 25. Now earlier P best we can see 41. Now G best is 13. So now what is happening? His grade is going to change. Let us assume that 41 may be A grade. Now this may be S grade, let us assume. Not in terms of marks, it is a, maybe in the rank fashion. Now we can see this is the more value and this is the less value. It is a minimization function. So we have to consider the minimum value is a best value. So then what is the updation? Your P best is going to be modified instead of 41. Now it has to become as a 25. Corresponding x values also is going to be considered. Now this is the new value. Earlier 41, 4, 5. X1 value is 4, x2 value is 5 and function value is 41. But above that is a 61 is there. That's why we keep on using this. But after some other iteration, we got updated value. Function value is 25. Now you have to compare 25 and 41. So 25 is the best solution. That's what we modified the P best. And what about the global best? Still, this is a 13. This one is 25. Therefore, 13 is the best one. We carry forward the 13 as such. Now in case 3, again, what is happening? Other case I'm telling. X1 value is 1, X2 value is 3. 1 square plus 3 square. That will be the 10. And what is the, with compared to case 1, modification you can see. Suppose this is the case. Now 10 and you have to compare with 41. Who is the best? 10 is the best. That's why you consider as a that solution is a p best. And again, global best also I compared with the current solution. In the previous iteration, we got x1 is 2, x3 is 3, x2 is 3, then G best is 13. Now in this solution, F is 10 only. Now what will happen? Now he is become individual best he updated and also globally he become as a class topper because when compared to other is the function value is minimum or you can say that fitness is more then it will become as a G best. That's why the G best also going to be updated. This is the P best updated, G best updated. Now we can see the above table case 1 better than its personal best now and better than it global best. So do not update P best and G best in case 1. You can see these two are best when compared to 41 to 61. 41 is best. That's why I marked it as a cross. And 13 we are comparing with 61. So 13 is best. So global best also not modified. That means both G best and P best is not modified. Now we'll come to the case 2. Case 2 case 41 compared to 25. 25 is best. That's why P best is marked. Means it is tick mark. Means that we are updated the P best. And similarly, whereas here 13 is comparing with 25. Therefore, 13 is the minimum only. So we don't want to change the G best. And you can see the third case, what we can do is 3, 10. This 10 compared with 41 is better. That's why this also modified. And 13 is compared with 10. That is better. G best and P best both is updated. Like that, some cases you can see if the P best is not updated, then do not update the P best or a G best. If this alone will not be possible because if this is the best, automatically that is also become as a best. Now this is the flow chart how we are going to happen in the algorithm. Initialize the particles that is the initial parameter whatever the number of populations and constant values and number of iterations, all these things will get it as a initial particle. After that, calculate the fitness value of each particle. Once calculating the fitness, we have to compare the current fitness value is better than the previous. If yes, then you can see the assign the current best new like what 4 cases I explained now that if no then keep the previous best then you can assign the particle p best value to g best value so then calculate the velocity of each particle then update the position and if it reaches the maximum number of iterations if true then and the program and results will be displayed. If not, you have to repeat this process this many number of times. This is the major flow chart. You can observe the, how it is going to be happen in the iteration process. So now we'll see in the next class how the problem is going to be solved using this algorithm. So if you have any doubt, you can ask. If you don't have any doubts, then you can leave.